Students, we have completed the theory part of your chapter Thermal Expansion of Solids, isn't it? And we have started discussing the numericals from this part, from this chapter. We have discussed some numericals, important types of numericals from the coefficient of linear expansion, okay, and we have started discussing the numericals from the superficial expansion part, okay. So I think we have discussed this sum number 6. We have completed discussing this sum number 6, and we will move on to the next sum, okay. Let's see what is the question given in the question number 7. The volumes of a hollow and a solid brass sphere at 0 degree C are both equal to 1 into 10 to the power minus 3 meter cube. I will explain also, don't worry. What will be their volumes on being heated to 86 degree Fahrenheit? Okay. The coefficient of linear expansion of brass is, the value is also given. Okay. So what is the question given, students? That you are having both a hollow sphere, hollow brass sphere, and a solid brass sphere. Okay. And their both temperature is at 0 degree C. Okay. And their volumes, the value of their volumes of both of the spheres is equal to 1 into 10 to the power minus 3 meter cube. Okay. Now what is the next part of the question? That what will be their volumes after being heated to the temperature 86 degree Fahrenheit. Clear? And what is the data given? The coefficient of linear expansion of brass value given. Okay. Now students, in this sum, if you just notice that here the temperature, the change in the temperature is given in terms of Fahrenheit, isn't it? But while we do the calculation, we keep in which scale of temperature? We keep the temperatures in which scale? If you remember that we always use the Celsius scale for the numericals. That means all the temperature should be there in the Celsius one. So let's first do that. So if you just go through the formula, students, we have discussed this. That is C by 5 equals to F minus 32 by 9. Isn't it? We did this formula. So here you can see C is there, that means Celsius there, and the Fahrenheit temperature is also there. So now our objective is to convert the Fahrenheit into the Celsius one. So let's write the value of Fahrenheit that is given in the question. So what is that value? 86 minus 32. Why? See the question. In the question, the value of the temperature is given as 86 by 9, isn't it? Just calculate it. You will get 30 degrees C. Okay. So the final temperature you will get as 30 degrees C. I was writing here. Final temperature equals to 30 degrees C. Okay. Now what we have to find out? See. The data that is given in the last part of the question, that is the coefficient of linear expansion. Okay. But as you can see that here, since all the volumes are given and you have been asked to find out their volumes after they are being heated to some temperature of this 86 degrees C, now we have converted it into Celsius 1. So you require the coefficient of the volume expansion, isn't it? Understood, students, why we are using the volume expansion part here? Because in the question you have been asked what will be their volumes after being heated to 86 degree Fahrenheit. This was the question. So let's find out the coefficient of the volume expansion, that is your gamma. How to put the symbol? Gamma. So gamma for brass will be what? Just go through the formulas. It is 3 into alpha. That means 3 into coefficient of linear expansion. So the value of coefficient of linear expansion is given. So I am writing 3 into that alpha. Alpha's value is what? 19 into 10 to the power minus 6 per degree C. Okay. Understood? Okay. Hope you can see it. Okay. Now we remember that a hollow vessel expands just like a solid vessel of the same volume, isn't it? Repeating once again. A hollow vessel expands like a solid vessel of the same volume. So the volumes of the both of these spheres will be the same at 30 degrees C, isn't it? So if this be V2, V2 means if this be V2 means if the new volumes after they're heated to this certain temperature, okay, so when the two spheres will be heated to this temperature, we can assume that the both of the volumes will be same, isn't it? So and we are assuming that volume to be V2 just for the calculation part. Then from the definition of the gamma, okay, what we can write? See what I'm writing. V2, again this is the formula, students. V2 is what? 1 into 10 to the power minus 3, that is a V1 part. Within bracket 1 plus this part 1 plus gamma, that part 3 into 19, what was given, into 10 to the power minus 6 into 30. Okay, and if you have to close the bracket, meter cube. Clear? Just go through the formula, students. I'm just repeating the formula. It's V1 into 1 plus gamma T. Okay, so just calculate it, you will get the answer. Okay, just the calculation you have to do.